You think you're sitting in a chair right now. You think your feet are touching the floor. You think you've touched thousands of things in your life, doors, tables, other people's hands. You're wrong. You have never touched anything, not once, not ever, and you never will. I know how that sounds. It sounds like philosophical word games, like I'm redefining what touch means to make some trivial point. But I'm not. I'm telling you something precise, something measurable, something Richard Feynman understood with perfect clarity. When you think you're touching something, what's actually happening is so strange, so fundamentally different from what you experience, that once you see it, you can never unsee it. Let me show you what I mean. Pick up your phone right now. Hold it in your hand. You feel it, right? The weight, the texture, the solidity of it. You think your hand is in contact with the phone. That seems obvious. But here's the problem. Your hand is made of atoms. The phone is made of atoms, and atoms are almost entirely empty space. Think about what an atom actually is. At the center, you've got a nucleus, protons and neutrons packed together. That nucleus is unimaginably small. If you scaled an atom up to the size of a football stadium, the nucleus would be smaller than a marble sitting at the center of the field. And around that nucleus, way out there, near the stadium walls, you've got electrons, tiny points of negative charge, orbiting in a fuzzy cloud. Everything in between? Empty. Nothing. Void. Your hand is 99. 9,9,9,9,9. 9% empty space. The phone is 9,9,9,9,9,9,9. 9% empty space. So when you press your hand against the phone, why don't your atoms just slip between its atoms like fingers through fog? The answer is forces, electromagnetic forces. And this is where Feynman's insight becomes crucial. Here's what Feynman understood better than almost anyone. The electromagnetic force between charged particles is monstrously, incomprehensibly strong. Take two electrons, just two. Place them 1 centimeter apart. The electromagnetic force pushing them apart is 42 times stronger than the gravitational force pulling them together. 10, 42. That's 1 followed by 42 zeros. That's a trillion, 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 trillion. The electromagnetic force is so vastly stronger than gravity that for electrons, gravity might as well not exist. It's background noise. It's irrelevant. So here's the question Feynman would ask. If these forces are that enormously strong, why isn't everything exploding? Why doesn't matter just tear itself apart? The answer is cancellation. Perfect, precise cancellation. Every atom has positive charges in the nucleus and negative charges in the electrons. Positive and negative, plus and minus. And they follow one brutally simple rule, like repels like. Opposites attract. The forces are exactly equal in magnitude. The push of repulsion equals the pull of attraction. In normal matter, you get an intimate mixture of positive and negative charges. Protons and electrons packed as close together as the laws of quantum mechanics allow. Every positive charge is surrounded by negatives. Every negative is surrounded by positives. And they balance out. The enormous repulsive forces are cancelled by equally enormous attractive forces. Everything is neutral. The forces are still there. Those monstrous electromagnetic forces are still acting, still pushing and pulling with unimaginable strength. But they're balanced so precisely that the net effect is zero. And because the underlying forces are so huge, even the tiniest imbalance creates effects you can feel. Rub a balloon on your hair. You move maybe 1 electron in every trillion. That's essentially nothing, but it's enough to make the balloon stick to the wall, enough to make your hair stand up, because when the forces are that enormous, even the smallest excess creates a noticeable effect. Now, back to your hand on that phone. When you press down, what's really happening? The electrons in the atoms of your hand are getting closer to the electrons in the atoms of the phone. And electrons hate each other. They repel with that enormous electromagnetic force. The closer they get, the harder they push back. At some point, the repulsion becomes so strong that your hand can't push any further. The electrons refuse to overlap. They push back with such force that it feels like solid resistance. That's what you're feeling. Not contact, not touch. Electromagnetic repulsion acting across a tiny gap. Your hand never touches the phone. There's always a gap, always. A tiny gap, measured in angstroms, but a gap nonetheless. The atoms in your hand and the atoms in the phone never actually come into contact. What you feel as touching is the electromagnetic force pushing back at you across empty space. This should completely restructure how you think about the world. Every push you've ever felt, every pull, every sensation of hardness or softness, of rough or smooth, it's all electromagnetic forces acting at a distance. You have never, not once in your entire life, actually made contact with anything. When you sit in a chair, you're not resting on it. You're floating above it, held up by the electromagnetic repulsion between the electrons in your body and the electrons in the chair. The gap is vanishingly small, but it's there. When you walk on the ground, you're not touching it. You're being pushed away from it by electromagnetic forces. Every step you take, you're hovering, suspended by invisible fields. When you hug someone you love, your atoms and their atoms never touch. You're two clouds of electrical charge, pressing against each other's boundaries, feeling the push of electromagnetic repulsion, but never actually making contact. Feynman understood this deeply. He understood that what we experience as the solid, mechanical world of touching and pushing is actually an electromagnetic illusion, and he was ruthless about stripping away the comfortable language we use to hide from this reality. People say, the ball bounces because it's elastic. That's not an explanation. That's just renaming the mystery. What makes it elastic? Electromagnetic forces between atoms. People say the table is hard. What does hard mean? It means the electromagnetic forces are strong enough to resist your pushing. That's all. Hardness is electromagnetic repulsion. People say, I'm standing on the floor. No, you're being electromagnetically repelled by the floor across a microscopic gap. Feynman would push you, don't use words that hide what's happening. Say what's actually happening. And what's actually happening is this. Every atom in your body is surrounded by a force field, an electromagnetic field, and that field extends outward into space. When another atom gets close, its field interacts with yours. The fields push against each other. The atoms never touch. The fields do all the work. This is not philosophy. This is measurable, testable physics. We can use atomic force microscopes to map these forces. We can measure the repulsion between individual atoms as they approach each other. We can see, with nanometer precision, that the atoms don't touch. We can measure the gap. We can measure the force. We can prove that contact is an illusion. And here's where it gets even stranger. This electromagnetic force that prevents you from touching anything, it's the same force that holds you together. The atoms in your body don't fall apart because the electromagnetic force binds them into molecules. Your DNA, your proteins, your cell membranes, they're all held together by electromagnetic forces between atoms. The same force that prevents you from touching the phone is the force that prevents you from dissolving into a cloud of disconnected atoms. The electromagnetic force is everything. It's the force that makes chemistry possible. It's the force that makes biology possible. It's the force that creates the sensation of touch, even as it prevents actual touching. Feynman saw this unity. He saw that all these seemingly different phenomena, static electricity, magnets, chemical bonds, the sensation of touch, are all manifestations of one force, the electromagnetic force. And he understood something else, something that makes this even more profound. The electromagnetic force doesn't just act between things that are touching, it acts at a distance, across empty space, instantly. Put a charged balloon near your hair. The balloon doesn't need to touch your hair to make it move. The force reaches across the gap. This isn't magic. This is fundamental. Force act at a distance. This violated people's intuitions for centuries. How can something push on something else without touching it? It seemed impossible. But Feynman understood that this discomfort comes from thinking contact is fundamental. It's not. The electromagnetic force acting at a distance is fundamental. Contact is the illusion we experience when things get close enough that the force becomes very strong. Think about magnets. You can feel them pushing or pulling across empty air. You're directly experiencing force at a distance. That's not a special property of magnets. That's how all forces work. Magnets just make it obvious because the forces are organized in a way that creates larger effects at larger distances. But at the atomic level, it's always the same. Charges creating fields, fields exerting forces, forces acting across space. Never direct contact. Always action at a distance. Feynman spent much of his career making this precise. He developed quantum electrodynamics, the theory of how charged particles interact through electromagnetic fields. He showed, with mathematical rigor, exactly how these forces work. He even won a Nobel Prize for it. And at the core of his theory is this insight. Particles don't touch. They exchange photons, virtual photons, particles of light that carry the electromagnetic force. When you think you're touching something, what's really happening is that electrons in your hand are exchanging countless photons with electrons in the object, and those photon exchanges create the repulsive force you experience as resistance. This is the operational reality. This is what's actually happening, stripped of all the comforting language about touching and contact. Now let's talk about what this means. Your entire sensory experience of the physical world is electromagnetic. Every sensation of touch, every feeling of pressure or texture or temperature, it's all electrons in your skin, interacting electromagnetically with electrons in the environment. Your nerves don't measure contact. They measure electromagnetic forces. They measure the push and pull of charges, and your brain interprets that as touch. You've been fooled by your biology. Your brain takes this purely electromagnetic information and constructs a vivid hallucination of a solid, mechanical world where things touch and push and pull through direct contact. But that's not what's happening. That's never what's happening. The truth is weirder, emptier, more electrified. You're a cloud of charges surrounded by force fields, floating through a universe of other charge clouds, never making contact, only ever feeling the push and pull of forces, acting across tiny voids. And here's what Feynman would say about that. This isn't a loss. This isn't disappointing. This is the truth. And the truth is always better than comfortable ignorance. Because once you understand this, once you really understand that touching is electromagnetic repulsion, you understand chemistry. You understand why some materials are hard and others are soft. You understand why things stick together or slide apart. You understand friction, adhesion, elasticity, all of it reduces to electromagnetic forces between atoms. You understand your own body, the shape of proteins folding, the copying of DNA, the firing of neurons, all electromagnetic. You understand technology. Every computer chip, every LED, every touchscreen works by manipulating electromagnetic forces at the atomic level. We've built an entire civilization on our ability to control these forces. And you understand something profound about reality itself. The world is not made of solid mechanical objects bumping into each other like billiard balls. The world is made of fields and forces. Charges creating fields. Fields exerting forces. Forces shaping the behavior of matter. Everything is electrical. Everything is a dance of attraction and repulsion playing out across empty space. This is what Feynman discovered. Not just the equations, though, he gave us those too, but the conceptual clarity, the ruthless honesty. The insistence on saying what's actually happening rather than hiding behind comfortable metaphors. When Feynman taught physics, he would say, "I'm going to tell you what nature is doing, not what it's like, what it's actually doing." And what nature is actually doing when you think you're touching something is this. Electrons in your hand are creating electromagnetic fields. Those fields extend outward. When they encounter the fields from electrons in another object, the fields interact, like charges repel. The closer the electrons get, the stronger the repulsion. At some point, the force is strong enough that your hand can't push any closer. You feel resistance. Your brain interprets this as contact. But it's not contact. It's force. It's always force. Never touch. Always force. That's the operational reality. That's what's measurable. That's what's true. And Feynman would say, isn't that better than the lie? Isn't it better to know that you're not a solid lump of matter, but an intricate arrangement of charges and fields? Isn't it better to know that the sensation of touch is actually your nervous system detecting electromagnetic repulsion? The universe doesn't care about your comfort. The universe doesn't arrange itself to match your intuitions. But the universe is comprehensible, and when you strip away the illusions, when you get down to what's actually operationally happening, you find something stranger and more beautiful than any comfortable lie. You find fields permeating all of space, charges creating those fields, forces acting across distance, atoms held together by electromagnetic attraction, atoms held apart by electromagnetic repulsion, everything balanced on a knife edge between the pull of opposites and the push of likes. And you find yourself, not a solid object, not a thing that touches other things, but a temporary, intricate pattern of electromagnetic interactions, a symphony of forces playing out in mostly empty space. That's what Feynman understood. That's what physics reveals. You have never touched anything. You never will. And that's not a limitation. That's reality. Not comfort. Not familiarity. Truth.